Bismillahirrahmanirrahim. What's up, ladies and gentlemen? Today I'm going to show you a design of isolated footing, and the question you'll be having in your mind: why should I learn isolated footing? The reason is very easy. Everything you do is to earn, okay? And secondary reason can also be for teach others, like what I'm doing right now. So let's get started. The meaning of design of footing means you're gonna say on the side based on the loads which we get from the building, what should be the thickness of the footing, what should be the number of rods, or we can say what is the diameter of rod you should put in the footing, and what should be the spacing that you should put. These are the things which are very important. You can actually say that thing on the side. And how do you say that thing? It's completely based on what is the load which is going to be applied from the building. Okay, so let's get started. What are the things which we need? Let us see. The first thing is the load, and this you can get from the stat pro or etabs. If you want me to teach you that thing, I'll be teaching that also, but just ping me. And if you want to have the complete course, you can again ping me on the WhatsApp. Okay, let's start. And here you can see we have the section of the column. This should be the inputs, and definitely you'll get that from the etabs or stat pro. Even you can get that thing from manual calculation, but it's really not preferable to do that thing. Okay, now let's move on to next step. That's busy. This you will get from the soil report and the grade of steel and concrete. You need to decide that what kind of building it is, like residential building or commercial, and what is the budget of the person who's creating that. But this is the standards. However, FE415 is not these days standards. FE500 is the standard thing which is going on as far as I know. However, based on your location, what is the grade of steel which you're getting in the market, you have to take that. Now let's move on. In this tutorial, I'm not going to show you all the numericals because that you can find in all the engineering classes, but I'm going to show you the practical ways how you can design that thing. And it's better that you don't do the pen and paper calculation every time. You do that thing in the Excel sheet because it's going to be real quick, and it's going to save a lot of time. So let's get started. As you know that these are the inputs, and if you have any problem getting this input, you can ping me. The first and the foremost thing regarding the load on the column, from the column you'll be getting is the ultimate load. The meaning of ultimate load is not the normal load, that is the standard loads which we'll be putting on the building. It's actually the factorized load. It means whatever load we are getting, we are going to multiply that thing with the factor of safety, which is 1.5, and then we take that thing. That's the meaning of ultimate load. So in design of footing, we don't take that ultimate load, we actually take working load. It means we're just not having 1.5. That's the reason we multiply this, actually divide this thing by 1.5. And then next thing is we need to calculate the self weight of the footing, and for doing that you have to take 10% of extra load, and you can see how we increase that by 10% here, and then we get that 10% load and working load, and we get the total. Next is size of the footing, and you can see for calculating that we have a formula, that is the load, this load, that is the working plus the weight of the footing divided by the SBC. And talking about the SBC, it's actually the safe bearing capacity, how much soil can bear safely, and dividing both of them we get some area, and we have to make that area in the dimensions. Like if you're taking the square footing, you have to just root that thing to get the sides. It's easy, I think, the if you have area of square, then you can just have its dimension by rooting the area. So this is how we take out the sides of the footing, and then we get some dimension, that is 1.47. That's one of the side, but however we have to increase that thing to certain value so that our footing shouldn't fail. Now next thing is we consider working loads. It's very important, the note that I wrote in the red pen. Let's move on to next page in the design steps. Yeah, in next step actually we have to calculate NUPI, and you might be asking what is NUPI. It's actually the pressure soil is going to put on the footing. like whenever we have this kind of section is section of the footing, the load is going to apply on the column, and you can see this is the footing. And we think that according to Newton's law, whenever the load is being applied or the force is applied, the equal amount of force should be applied on the opposite side so that the thing should be remain on its position. So we think that soil is going to apply force on the footing, and this force is actually known as NUPI. It is net upward pressure in density. So we have that thing to how do you calculate that? We have this formula, load by area provided, and you have the load and what is the area we just now calculated, 1.5, and the value should always be lesser than SBC, and then it should be safe. Obviously this NUPI, if it is greater, then soil will not be bearing that load and it's going to fail. Okay, let's move on to next thing. um, if at all we are getting this value less, then this is the note you have to follow. We have to just revise the dimension of the footing. What's the next thing? Usually I say when we design the footing, we have to calculate how much the diameter of rod is there and what's the spacing we have to provide between the rods. And for that thing, we really need moments. If you know RCC, in that thing, every time we calculate the steel, area of steel, and then we calculate what is the number of rods or the diameter of rod, what is the spacing, and for that thing, you really want the moment. So how will you get that thing? Footing is a inverted cantilever beam. Just think that this is the fixed support and this is the free support, and you can see there is a UDL which has been applied. And for calculating the moment for the cantilever beam on which the UDL has been acting, you can easily know the formula is W squared divided by 2. And you know what is W? It is actually the NUPI, that is the load which has been applied from the downside. You already calculated this thing, and you will be having the length. I'll show you how we will calculate that. Because the footing is not just kind of beam, it will be having the X side cantilever part and even the Y side cantilever part. Like I'll show you here. This is what I'm talking about. This is the top view of the footing, this is the column, and you can see this is the cantilever portion and there's another cantilever portion. So we'll be having different lengths here, so we have to calculate length in X direction and what's the length in Y direction. For calculating this length in X direction and Y direction, we have to do certain maths. You already know that we have the dimension which we take as 1.5 meters. From that thing, we actually subtract the column dimension, and then once we subtract this column dimension, we'll be getting the portion this and this, and by dividing it by 2, you'll be getting one of the side. So this is what we did. So you can see this is how we get the LX. We take the whole dimension, or yeah, just don't divide to these two things. You can just divide whole of it by 2. You'll get something as LX. And after doing that, what you have to do is you need to do the same thing to the Y also, and you'll get that thing. And then you'll be having the MX and then MY, and you already know what is the meaning of MX and MY here. 1.5 W squared divided by 2, and the L will be varying, like LX will be there and LY will be there. So just substitute the values, you already know the W, and you get MX and MY. After doing that, we need to move on to the next step, that is the depth required, and we'll see that thing in the next tutorial.